Hello students, I hope you all are doing well and good, right? So in today's class, we will be discussing a very important chapter, that is trigonometry, right? This is a very important concept that we are going to discuss in today's class. And in this class, I will be teaching you the basic concepts till advance of trigonometry, where we will be discussing all about the sign notation, the periodicity, reference angle, and what are trigonometric ratios, what are trigonometric identities, right? So these are the basic concepts I will be teaching you in this class. So everybody just get set and ready for the chapter that is trigonometry, right? Okay, so let's start with our new chapter, that is trigonometry. Here you can see that if I just split this word trigonometry into three forms, right? So here you can see that it has been splitted and we got three words out of this. The first you can see here, it is tri, right? And if you just add here gono plus metry, right? So what would happen if I just split these three things or three words? So what is the meaning of tri? The meaning of tri is three. The meaning of gono means sides, where the meaning of metry is measurement. So here we will be discussing all about the figures that all having three sides. So can you tell me a polygon name which is having three sides? Can you guess what is that? Yes, that's the correct answer. Basically, it is a triangle. So here we will be discussing about the triangle, right? Because it is having three sides. And specifically, if I talk about the triangles, we will be discussing all about right angle triangle. Right angle triangle. What does it mean? It is having one angle at 90 degrees, right? So let's start with the introduction of trigonometry. So basically, trigonometry deals with the relationship between angles and the sides of triangle. Here we will be discussing about the sides and angles, right? There's a basic important thing that we will be doing, where we will just have the discussion based on their sides. Like let's suppose we are having a triangle A, B, C, which is having side AC, AB, and BC. And here we are having a three angles, that is theta 1, theta 2, and let's suppose here as a theta 3. So here this is represented as a theta, right? We say it as a theta and it's made like this, right? So here we will be just dealing with the relationship between these angles and the sides of a triangle. Particularly, we are looking for the right angle triangle, where we know that the angle is of 90-degree measure. Where you can see that trigonometry is derived from the Greek word that is said to be trigono, that is triangle, and metron means measurement. So this is a basic concept, right? Or basic terminology that we have discussed. Now, let us move further and discuss the terminologies that we are using this chapter. The first, here you can see that we are having basic components. That is, first one is angle. If I just talk about angle, so it is formed by two rays meeting at a point, right? And it is measured in degree. Generally, degree can be written like this. So degree is like this, right? If I say that, for example, I write 12 degree. So this part is said to be as degree, right? Or the angle can be measured in radian, that is said as rad. In short, and is pronounced as radians or radian, right? Now, the next thing that we are going to discuss is right angle triangle. So let's have a construction first that will be more feasible for us to understand the concept, right? So as you can see that, let me draw a right angle triangle. Now here you can see that if I just have a right angle triangle like this, let us name it as PQRS. Here is PQR. Now here we are having a 90 degree at Q. As you can see that a right angle triangle, one angle is equals to 90 degree, right? And here we have three things like hypotenuse, which is represented by H. Second thing we have, that is opposite side. And third is adjacent side. So let's suppose if I take a reference of this, an angle as this is theta 1 at P. So can you tell me what is the adjacent side of angle P? So you will say this is QP, right? Is that? Yes. Now, if I just say, what is the opposite side of angle this? So it will be this? No. Here we will be just looking after the opposite side that will be found by seeing the angle 90 degree. So this is the opposite side, basically. right? So we have understood that if we are just talking about the opposite side, it is said to be as hypotenuse, where this is said to be as perpendicular, and the basement part, or this is said to be as base, right? So as we know by Pythagoras theorem, that is hypotenuse square is equals to perpendicular square plus base square. This is the Pythagoras theorem that we have learned in our previous classes, right? So here you can understand what is hypotenuse. Hypotenuse is the side opposite to the right angle and the longest side of the triangle. So always keep in mind this side, that is PR, is the longest side of the triangle. Now, if we just talk about opposite side, the side opposite to the angle of the nearest. So here we can see that we have taken this reference angle as P, that is equals to theta. And what is the opposite side of that? That is QR. That is said to be as perpendicular, right? That is said to be as perpendicular. That is QR, right? And if we just say that adjacent side, so here the next side, which is to the angle of interest, or we have taken the reference angle, that is said to be as base, as we have discussed. So here the base side is what? It is PQ, right? So we have discussed all about the Pythagoras theorem over here. Now, further we will be discussing all about what are trigonometric ratios. So the primary trigonometric ratios are defined based on right angle triangle. As I told, one of the angle will be 90 degree, right? So angle, for any angle we use theta as a reference, or you can say the given angle, but generally this is said to be as theta, right? Yeah. Okay. So now let us move further and discuss the further things. So here you can see that it is unit circle. The unit circle is a circle with a radius 1 centered at the origin. As I told you, let's suppose this is our axis and this is origin is O, that is 0, 0, right? We are just talking about the coordinate plane. So the trigonometric function that we will be having, like, that is sine theta, cos theta, and tan theta. Whereas if you just see here, so sine theta, it belongs to the y coordinate of the point on the circle, whereas cos theta belongs to x coordinate of the point of a circle, whereas tan theta is what? That is y upon x, that is slope, or as we have discussed, the gradient of that, right? So we will be discussing deep dive. Do not worry. We will have a diagram. We will discuss this topic in very deep dive manner, and we will understand how it is being derived, right? And do you know what are the application of trigonometry where we will be using that? So let me tell you that applications of trigonometry are like, if you just see the angle of elevation and depression, what does it mean? Let's suppose a boy is standing here, right? And he is seeing the top of the building. This is building, right? This is the building, and he is standing in the road. And you can see that he is just seeing the top of the building. So this angle is said to be as angle of elevation. Angle of elevation, right? And if I say that a boy is standing at the top of the building and he is just seeing the road. So here this angle is made, is said to be as angle of depression. It is said to be as angle of depression, right? Okay. After that, we use this trigonometry in the form of like navigation, calculate direction and position of something. In physics, we used to analyze oscillation, waves, and force, how the waves are formed, like these waves are formed, right? We will be discussing in the trigonometry here in the second part of this chapter. Do not worry. And in the fourth, that is engineering. We design, construction, structure, and solve some mechanical problems. These all are based on trigonometric chapter. So now you can understand what is the most important thing we have to learn class, that is trigonometry, right? Because it will come in all of our part of life, that is elevation, navigation, physics, and engineering, if you do that, right? Okay. So now let us move further. As you can see that the distance or the height can be found by using some mathematical techniques which come under the branch of mathematics called trigonometry. If you just talk about the distance, height, so these all techniques come under which, like a branch of mathematics, that is trigonometry. And if you just see that trigonometry is derived from the word, like I told you, 3 sides measurement, right? So basically, if you just talk about what is a trigonometry, it's basically study of relationship between the sides, that is S, and the angles of a triangle. Whenever we are just talking about a triangle, so we have to just keep in mind that is we all are talking about the right angle triangle that is specifically in trigonometry, right? Where we will just look after the sides and the angles, and here we will just suppose angle as theta, right? And here we will have the side adjacent sides, or you can say opposite side, or the reference angle that we all will be discussing over here, right? Now, so do you know where these have been founded from? So here you can see that the earliest known work on trigonometry was recorded by Egypt and Babylon. They have all worked on it and they have derived this form. So we will study some ratios of the sides of a triangle with respect to their acute angle. It means that, let's suppose I'm having a right angle triangle 90 degree at this, like this is P, Q, and R, right? And if I say that this right angle triangle at Q, we should have some acute angle with reference angle. So let's take as theta. So basically this is an acute angle and this will be also an acute angle, right? To make a triangle. So as the property says, right? But if we just say that what is the acute angle? So we will just say that we have taken this as a reference angle to work for. So this is basically a reference angle that we are seeing, right? Okay. So after that, we will be discussing about the trigonometric ratios. Basically, we have 6 trigonometric ratios. The first one is sine, cos, tan. Then the second one is like sec, cosec, and cot. So these all are the trigonometric ratios that we are going to discuss, right? Okay. So here you can see that we will discuss this. I'm just giving a basic ideology of the introduction, and after that, we will discuss each and every part in detail. So do not worry about that. So here you can see that if I say I'm having a triangle CAB, let's suppose we are having a triangle CAB, and which is right angle at A. Here you can see that angle A is an acute angle. No, here we have just taken another example, like let me take here as A here and B as right angle. So this is an acute angle, right? Yeah. And here you can see that note the position of BC with respect of angle this, right? So here we are just seeing the opposite side. Is that? Yes, that is opposite side. So here it will become base and here it will be perpendicular and this will be your hypotenuse. How it happened, I will be explaining it. Do not worry. So these are all the trigonometric ratios that we will be discussing. Now, let us discuss all about what are bearings. So if we just see that bearing or the compass bearing is the direction measured or as an angle from north, that is clockwise direction. Generally, we used to move like this, that is a clockwise direction, right? So if you see here it is making 150 degree, right? This is east, north, west, south. So the direction of bearing of angle is 150 degree. That is 150 degree, right? Yes. So here we just see the angle made in the clockwise direction, and that is said to be as the bearing of an angle, right? Okay, sure. Now let's understand the basic concept, right? And we will just have a detailed analysis of each and every topic now. So everybody just focus from here, right? As I told you, one boy is standing. Let's suppose I'm saying that one boy is standing over there. So to make it proper, let's have a line, right? Okay. Let's suppose I'm having a line like this. Oh, 1 minute. Yeah. Let's suppose I'm having a line this one, okay? And let's suppose here is a road and this is the thing. Now let us name it as like one boy is standing over here and he wants to just see the top of the building. Here you can see the top of the building when tower is present, right? So his eyesights are like this, it is going upside. And here we are making an angle like this, as we are seeing, let's suppose as theta, right? So this angle which is made, it is said to be as angle of elevation. This is said to be as angle of elevation, right? And let's suppose if you're just having opposite or inverse case, what would happen, right? So if I just say that, let's suppose one boy is at the top of the building and he is watching something like car which is on the road. So let's suppose one car is present over here. Okay. And one of the boy is present at the top of the building. He's watching the car like this. The direction will be in downward direction. And here we are making an angle like theta, right? So what does this angle says? This angle says that angle of depression. Angle of depression. So these are the two angles we've just formed when we see from bottom to top and from top to bottom. So we form two types of angle, like angle of elevation and angle of depression, right? And it can be like both together? Yes, of course it can be. How? So let me tell you that. Let's suppose we are having a father and son. They're walking from distance, like one of the parent is here and one of the parent is here. They are just moving the same direction and they are just seeing the top of the building from here on, right? So if you just see that, let's suppose the female parent is here at position A and male parent is at this position, that is position B. And just you can see that here were two things we can form. Let us take the two parent once again. Let's take another case. Let's take the first case. That is, let's suppose both the parents are here. Let's suppose that both the parents are here and just seeing the tower 1 of the hotel and just seeing the tower 2 of the hotel. So in both the case, they are making an angle. For the triangle 1 we are talking, it is making angle as theta 1, right? And if we just talk about the second triangle, which is 90 degree at this, it is making an angle theta 2. So these are the two cases where both the angles which are being made, it is said to be as angle of elevation. This is all are said to be as angle of elevation, right? I hope it is very clear till now. What is angle of depression and what is angle of elevation? Now, to understand the concept of trigonometric ratios, let's have a proper knowledge of what is trigonometric ratio and how we can just derive and come to that. So let's discuss all about trigonometric ratios. To have that, let's have the two cases that have the first case, right? So let me draw one triangle that will be more feasible to understand, right? Let's suppose here we are having a right angle triangle and we name it as ABCD, right? And which is like here we are having A, B, and C. We are having a right angle triangle which is right angle at B. It is of 90 degree, right? So as I said, like this is the side AB, this is side BC, and this is side AC. And we are having a right angle triangle. Now here you can see that this is adjacent side. Here you can say that this is adjacent side. Why? Because we are taking the reference angle theta as angle A. So this is adjacent side, right? And if we just see that opposite sides from this, so it will be opposite side. That is opposite side from the reference angle that we have taken, that is theta, right? Now, as I have told you, this will be what? This will be perpendicular. This is said to be as perpendicular. Whereas the adjacent side is said to be as base. And the upper part that we are having, it is said to be as hypotenuse. Hypotenuse. Yes. Okay. So it is represented by capital H. It is represented by capital P. And is represented by capital B. Now, if I would say like, if we just apply the Pythagoras theorem over here. So let us see what the changes that we can have. So by Pythagoras theorem, if I just say that, okay, so here it will be hypotenuse square is equals to perpendicular square plus base square, right? So here we are having the reference angle as angle A, right? So if we just substitute the value of this, here we will be having a hypotenuse as AC square. Perpendicular is what? That is BC square and base it is AB square. So this is the identity when we have taken the reference angle, to whom the reference angle that we have taken as theta, that is angle A, or you can say that this is our acute angle that we have taken to understand the concept, right? This is our acute angle that we have considered. Okay, so this is the thing that we have got. Now, if I just change the case and take reference angle at C, what would happen? Just have a key eye on this, because this is the very important thing that we are going to have, right? So let us consider the second case. Now, let's suppose I'm having a right angle triangle like this, which is like ABCD, same we will be taking. It is A, B, C. And here we have a 90° at B, where angle B is 90°. And here we will just take the reference angle or theta at angle C. Now here you can see that. Now here the changes will be coming. How? I will explain you, do not worry. So let us suppose that this is what? This is now adjacent side. So here you can see that this is an adjacent side with the reference angle as C, right? So this is your adjacent side. Now, this is what? This is your opposite side. So here you will be having as it opposite side, right? Now, what will be this? So as I told you, this is the opposite 90 degrees. So it will be hypotenuse. It will be hypotenuse. So whenever we are just changing the reference angle or the acute angle, then what are the changes that we can see? So here we can see that the perpendicular and base are being changed. So always keep in mind, whenever we are just considering the angles, it matters that the perpendicular and the base are just exchanging with there, right? So here, if we just say that by applying Pythagoras theorem, so it will be hypotenuse square is equals to perpendicular square plus base square. So now here you can see that this is hypotenuse. This is what? This became perpendicular. No, this became base. This is a base, because this is the reference angle. It is adjacent angle to the reference angle. And this is the opposite side, then it will become perpendicular, right? So if I just apply the formula, so what is the hypotenuse that we are having? That is AC square is equals to, what is perpendicular now? It is basically AB. So here you can see that it has been changed, and the base will be BC square, right? Now I hope you all have understood this well, right? Yes, just make a note of this. So this is equation number 2. So whenever we are just having the changes in the reference angle, the adjacent angles, here the adjacent angles you can see, or you can see that adjacent sides are being changed, where the opposite sides are being changed. It means that the perpendicular and base are being shifted, and this will make a new complication, right? So this was all about these things. Now, what are trigonometric ratios? So basically we have 6 trigonometric ratios. So basically we have 6 trigonometric ratios. Okay. Now, what are they? The first one that we have is sine. So basically it is like this, but in short it has been written like sine. Okay. The second one is cos. Third one is tan. Fourth one is sec. Fifth one is cosec. And the sixth one is cot. So basically we have 6 trigonometric ratios, and these ratios also have some values, right? So that is a major part that we have to understand now. If I say that, what is the trigonometric ratio of sine theta? We are just taking the case number first, or let's suppose a triangle over here. That will be more feasible to understand. Let's draw a figure. Okay, yeah. Now, let's suppose we are having a triangle PQR. Let us consider a triangle PQR, right angle at Q, right? And if I take the right angle Q, and we are just taking the acute reference angle as P, that is theta. So this side will be what? Now this side will be opposite side. This side is what? This is opposite side, right? And now This part will be becoming what? It will become the adjacent side. This will be adjacent side now, right? Okay. So as I have mentioned you earlier in the previous case 1 and case 2, so this will become what? As we know that it will become hypotenuse. That is represented by H. And if I just see that, this will become what? This will become perpendicular and this will be base, right? And we are just talking about the reference angle theta, that is angle P. Now, if I just said, what are the values of trigonometric ratio for this? So the first value that we are going to study is all about sine theta. We are just taking the reference angle as theta. So the formula is perpendicular upon or by hypotenuse, right? That can be written as P upon H, or if we just substitute the values over here, so it will become, what is perpendicular? So the perpendicular that we are having, that is QR, and hypotenuse that we are having, that is here. So this is the first trigonometric ratio that we have formed from right angle triangle with a reference angle as theta at P, right? Now, let us see for the further more things. What are the trigonometric ratio? The second one is cos. The second one is cos theta. What's the formula for that? So for the formula for cos theta is base upon hypotenuse. Base upon hypotenuse, right? So it will be B by H. What is base over here? What is base? So you can see here the base we are having, that is PQ upon hypotenuse is PR. So we have got the second one as this one, right? And if I just move to the third one that we will be seeing, that is tan theta. It is what? It is perpendicular upon base, or you can say perpendicular upon or by base. So what is the perpendicular that we are having? That is QR. And what is the base? That is PQ. So these are the three trigonometric ratios. And further, if you just see the fourth trigonometric ratio that we are having, that is sec theta. That is what? The reverse. You can say that it is the reverse, or you can say that inverse of cos theta. That will be hypotenuse upon base. So hypotenuse is what? That is PR upon PQ. The fifth ratio that we are having, that is cosec. That is inverse of sine. So it is what? It will become hypotenuse upon perpendicular. What is hypotenuse over here? That is PR, and perpendicular, that is QR. And the sixth ratio that we are having, that is the inverse of tan theta. Okay, inverse of tan theta. So that is cot theta. And if we just see that, see here what it will become? It will become inverse, right? So it will be base upon perpendicular. What is base? That is QP upon, what is perpendicular? That is QR. So these all are the 6 trigonometric ratios. So let me derive you some more important phenomena of this. As I have told you, sine is inverse of cosec. So always remember like this. Cos is inverse of sec, whereas tan is inverse of cot. So these are the trigonometric ratios that we have discussed. What are the important formula for that? How we can just derive the important formula and substitute the values to calculate the trigonometric ratios of any right angle triangle that has been given with some reference angle. It may be both the cases. For the first case, the reference angle may be this one as well. Or for the second case, the values will be changed, but the reference angle will be changed like this. So the reference angle changed, the value also will be changed, right? So always think like this is hypotenuse, this is perpendicular, and this is base. And when the reference angle is changed, then it always be this one is hypotenuse, but this is changed, it will become base and it will become perpendicular. Basically, these changes happen. So always just keep in mind to look after the acute angle that has been presented, to look after like this and this. Always this is the most important thing that we have to always keep in mind, right? Now, if I just say that positive and negative angles, let's have a discussion based on that as well. If I say that positive and negative angles, what are they and how we can calculate that as well? So if I say that positive and negative angles, so the first one, if you say, to that we have to draw one plane, to just make sure that each and everything we have understood. Okay. So now, if I say that we are making an angle from here, right? Let us suppose that we are making angle. Okay, 1 minute. 1 minute, please. Let us take in the white form, right? Now, let us suppose I have taken Cartesian plane where I have told you the axis, right? So let us make a remembers as well. So here you can see that this is said to be as the intersecting point O as origin. This is X, this is X dash, this is Y, this is Y dash, right? And let's suppose one angle is being formed from here. And if I just say that, what is the angle measurement? So from here to here, the angle measurement is 135. But it is positive or negative? So it will be positive because we are just moving like this, right? So here all the trigonometric ratios are positive, and here the trigonometric ratios are being changed because we are having the 4 quadrant like 1, 2, 3, and 4. So in this case, the first case, the trigonometric ratio, the angle will be positive 135 degree. But if I would say that for the second case, let us consider for the second case here. If I just say that we are having the same thing, okay, axes are here. Now, if the angle we are having that is in downward direction like this, right? So here you can see that this is your y, this is y dash, this is x dash, this is x, and this is the intersection point O. Here we are having an angle of 30 degree, but this will be now negative. Why? Because here the angle is in down form. Here the ratio angles are in negative. So here we have made an angle of negative, that is minus 30 degree, right? I hope it is very clear till now, right? Okay. So now here we have discussed many more concepts in this today's class. So make sure that you all make the revision for that because that will help you a lot to understand the deep concept of this, right? And we will just solve each and every question from this concept, understand the concept, solve the trigonometric ratios, concepts, and angle, how we have to calculate each and everything, because that's the most important thing, right? So I hope you all enjoyed it, learned the concept very well in the class. And if you're having any doubt, you can just tell me, right? So we will have a discussion of them. I will explain each and everything many more times. No worries, with easier and simpler methods. So now in the next class, we will be just having the problem based on this concept, and let's us discuss more deep dive concept all about the ratios, how the angles have been calculated. Each and everything we will be discussing in the next class. Till then, enjoy, complete your homework, and if you're having doubt, you can just ask me. So let's meet in the next class. Till then, take care. Bye-bye. We will meet in our next live session. We will meet in our next live session. Okay. Chalo. So till then, see you. Bye-bye. Thank you. Take care. Bye-bye.